Welcome back. This is a new video about the continuous probability distributions, and in this case the normal probability distribution. And here I'm going to introduce the z-score. Basically, we're going to normalize or standardize the normal distribution. Now, when we look at the normal distribution, typically we had different parameters. The x value that we want to, for which we want to find the probability, or the value of the density distribution. We have the mean, we have the standard deviation, and these are parameters which are, let's say, not so interesting because we have to calculate all of these things, all these parameters for every value of the mean and the standard deviation. And basically what we want to get is a distribution that we can use in all circumstances. We can just make those tables, and we will use those tables, standardized tables, to calculate the probabilities. Now, what we're doing is, in fact, what we're going to express is how many standard deviation x is to the left or to the right from the mean value. When the standard deviations are to the left, then we have negative values for the z-score, and to the right we have positive values for the z-score. Now, when we look at the formula for standardizing, we say that the z value is equal to the x value, the value I'm evaluating, minus the average divided by the standard deviation. Basically, we are transforming the normal distribution in a normal distribution with an average equal to 0 and a standard deviation equal to 1. And we can use this distribution in a simple way for any value x, mu, and sigma. We just calculate the z value, and the z value gives us how many standard deviations x is to the left and to the right of the average. The bell curve is the same, and the probabilities will be the same also, but the calculations are a lot easier because we only have to use one type of tables. Now, when we look at this table, there are different values, different tables that we can have. And we have a table where we find the value to the left of x, or to the left of the z value. And here we can say with the z-score, it gives the surface for all values smaller than the average plus z times the standard deviation, a number of standard deviations to the left or to the right. Now, this type of tables, we can find that we have a table where z is equal to 0. We see that there is 50%. So basically, this table gives the probability to the left of the z value. We find it for different values. Let's have a look for a simple value, z equal to 0.23. So we have x is in fact the average plus 0.23 times the standard deviation. We have a positive standard deviation. It means that x and z are to the right of the average. In this table, we can also have negative values. So basically, the table doesn't start from 0. It starts typically or from -4, because from there the values are very low, up to +4. Around +4, you will have a probability of 1. So basically, we see that these tables are limited from a negative z value up to a positive z value. Now, the first thing we do, we see z, we see 0, 0.1 up to 0.5. We select the row where we have 0.2. And on the top row, we see the next decimal. So for the first row, we find 0.20. For the second row, we find 0.21. We want to have 0.23. So now we find the column where we have 3. And we find the intersection between the 0.2 and the 3, which gives us, in this case, 0.5910. It means that there is 59.1% to the left of z, to the left of x. Basically, we can say there is 59.1% probability that the values of x are smaller than, in our case, the corresponding z value 0.23. And we find that surface is the gray surface. The gray surface to the left of the z value is 59.10%. Now there are different types of tables. There is also a table where we find the surface between the average and the average plus z times sigma, or between 0 and z. We can recognize these tables because for a z value z0 we find 0 because z is equal to 0. There is no surface between z and the average. We're straight on the average. And in fact, we do the same principle here. For z equal to 0.23, we first select the row where we have 0.2. Then we select the column where we have 3. The intersection is 0.23. It gives us now 0.091%, or 0.091 or 9.1%. So basically we find that this surface here is equal to 9.1%. If we want to know everything to the left of that z value, we have to add 50%. When we want to know everything to the right of this z value, we have to subtract the 9.10% from 50%. But we will look into that in some exercises later on. So basically now you have an overview how to read the tables, what different tables there are, but there is more and we're going to look at that in the next videos. Anyway, don't forget to click the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. I thank you very much and I'm looking forward to seeing you in our next video. Bye bye.